Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge O-Levels Physics 5054. Today we have set our hearts to solve a paper 2. For this purpose, we have selected May-June 2024 2 paper. This theory paper, paper 2, belongs from the zone 2. In this video, I'm going to present you the solution of this paper to the best of my knowledge, my abilities, and my skills. The solution is written by one of my students, and we are thankful to her. The paper, the marking scheme, and the examiner report, which we are using in this video, those three things are the property of the Cambridge Assessment International Education. The paper, the marking scheme, and the examiner report has been created by the CAIE. So we are thankful to them. I have just downloaded these three things from their website and I'm using them in my video. So let's start today's paper. So here we go. So the question is showing up on your screen. This is the question paper, May-June 2024. The time allowed for this paper is 1 hour and 45 minutes. All the questions you have to attempt in this. There is no choice in the paper. And the value of the G in this paper will be taken as 9.8 meter per second square or 9.8 Newton per kg. The total marks for this paper are 80. So let's go to the question number 1. So on your screen, question number 1 is showing up. Figure 1.1 shows two trolleys. On the front of trolley A, there is a wooden rod. Trolley B is initially at rest. As the trolley A moves towards the right, the rod enters the modeling clay. The trolley A slows down and trolley B starts moving. The trolley then sticks together. The trolleys then stick together and continue moving towards the right. Figure 1.2 shows the speed time graph for the two trolleys. So if you look at this speed time graph, on the y-axis, the speed is represented, and on the x-axis, the time is represented. Here you can see from 0 to 0.3, the trolley B is at rest. The velocity is 0. From 0 to 0.3 seconds, the trolley A is moving at the constant speed of 0.7 meter per second. And at 0.5 seconds, they started moving at a constant speed of 0.4 meter per second, and they stick together. From 0.3 to 0.5 seconds, the speed of the trolley B is increasing, the speed of the trolley A is decreasing. So let's see, the trolley starts to collide at the time t equals to 0.30 seconds. At t equals to 0.5 seconds, the trolleys are moving at the same speed. Question number 1A is first part. State how the figure 1.2 shows that during the collision, the trolley B has a uniform acceleration. So how does this shape shows that this speed time graph shows that the trolley B is moving at a uniform acceleration? You know, the speed time graph, its gradient represents the acceleration. And you can see from 0.3 to 0.5, the speed time graph of the trolley B is represented with a straight inclined line, which means that the gradient is constant. So of this graph from 0.3 to 0.5 seconds, which means that the trolley is moving at a uniform speed. So let's see what the answer we have. This answer is written by one of my students, and we are thankful to Aima for writing these solutions for us. So we will see if she has written the perfect answers or she has made some mistakes. We will discuss them. It's a straight line. So she just wrote that it's a straight line. The speed time graph for the trolley B is a straight line from 0.3 seconds to 0.5 seconds. I hope you understand. So let's go to the marking scheme and check what the marking scheme has to say. Okay, so here we have question number 1, marking scheme showing up on your screen. You can pause the video and take your time with this marking scheme. Okay, so straight line on the speed time graph. Okay, so let's go to the next part. Question number 1A, second part. He said, describe how the graph in the figure 1.2 shows that the magnitude size of the acceleration of the trolley B is larger than the magnitude of the deceleration of the trolley A. Okay, so how the size of the acceleration in the trolley B is larger? Okay, you see the change in the velocity is from 0 to 0.4. So there's a change of 0.4 velocity in 0.2 seconds. But for the trolley A, in the same time duration, in the same time, from in 0.2 seconds, the trolley A's speed, the change in the speed is only 0.3 meter per second. So you can see in the same time duration, the trolley A has a change of 0.3 meter per second in the velocity, and the trolley B has a 0.4 meter per second change in the velocity. So the trolley B has more acceleration. In other words, you can say that the trolley B's graph is more steeper from 0.3 to 0.5 seconds as compared to the steepness of the speed time graph for the trolley A in the same duration. So I hope you understand what I'm saying. Here, the IMA says that the gradient of the line B is steeper from 0.3 seconds to 0.5 seconds than that of the A. So this is how we wrote this answer. You can have a look at the marking scheme. Question number 1A, second part, gradient of the line steeper for the B or larger change in the speed in the same time. I hope you understand. I hope you can write this answer. So let's go to the next part, and it says question number 1A and its third part. He says, calculate, their question is calculate the acceleration of the trolley B when the time is equal to 0.40 seconds. So if you want to find out the acceleration, so on 0.40 seconds, so basically they want to find out the acceleration at this point. So because this is a straight line, so I will take 2 points on this straight line. Any 2 points I can take. For example, I can take 0.3, 0, 0.5, 0.4, because here this is a straight line. So take 2 points on this straight line and find their gradient, because this is a speed time graph. When you will find the gradient, that gradient will be equal to the acceleration. So we will do this, and we have taken 2 points. One point is 0.3, 0, and the other point is 0.5, 0.4. And we apply the formula, the gradient formula, or you can say acceleration formula. That is v minus u divided by t, or you can say change in the velocity divided by the change in the time. So 0.4 minus 0 divided by 0.5 minus 0.3, that's 0.4 divided by 0.2, and that is equals to 2 meter per second square. So the acceleration is 2 meter per second square. So it's a straightforward question. I hope you understand. So let's go to the next part. That is question number 1, 3 part. We are done. Now we are going to attempt question number 1 and its B part. So question number 1 and its B part is showing up on your screen. It says that the mass of the trolley is mass of the trolley A is 0.80 kg. The mass of the trolley B is 0.60 kg. Show that the momentum is conserved in the collision. So you see the momentum is conserved in the collision. That means the momentum before the collision and the momentum after the collision, both the momentums are equal to each other. Momentum before the collision and momentum after the collision. Before the collision, you know, that is the mass of the A multiply the velocity of the A before collision plus the mass of the B multiply velocity of the B. So velocity of the B before the collision is 0. So we will have 0.8 multiply 0.7 plus 0.6 multiply 0. So that will be 0.56 kg meter per second. Momentum after the collision, and that will be because now they have stick together. So I will take they are acting like a single mass. So trolley A and trolley B, they both are together. So we will take their total mass and we will multiply with the velocity after the collision. So we will have 0.8 plus 0.6. We will add these two masses because they are now together. So we will have 1.4 kg and we will multiply it with the velocity that is 0.4 and that will be 0.56 kg meter per second. So you can see here clearly our calculations are showing that the momentum before the collision and the sorry for the inconvenience. Something happened with the internet, and that's why there was a breakdown in the internet. And now we are back. And you can see here that the momentum before the collision is 0.56 kg meter per second, and momentum after the collision is also 0.56 kg meter per second. So let's check from the marking scheme. What does the marking scheme says? Marking scheme says that the gradient initial momentum and the final momentum, they will be equals to each other. Okay, so this is how we showed it. And here we go. Now we are going to the C part, which is of 2 marks. In another collision between the same trolleys, the rod and modeling clay are not present. Trolley A hits the trolley B with the same initial speed. Explain why the force between the trolleys is larger in this collision. You see, you remember that the formula for the force is change in the momentum divided by time. So when this change in the momentum divided by time means that if the change in the momentum, the same change in the momentum will take place, but this time when there is no modeling clay, the time taken will be less because there is no modeling clay. So the change in the momentum will have a small in a shorter time. So the force, which is change in the momentum divided by time, rate of change of momentum, so that will become larger. Okay, so because the same change in the momentum now will happen in less time. So that's why a larger force will be created. So let's see what my student has written. And she says that the contact forces are more rigid and decreases the time of contact. Change in the momentum will occur in less time. So the acceleration and force and impulse increases. So this word impulse is not right. Impulse is still the same. Impulse means the change in the momentum. So don't write this word. Let me take the marker. So don't write this word impulse. Impulse is basically change in the momentum. The change in the momentum is still the same, but that impulse took place in less time. So or simply say that the force increases. Don't say impulse increases, okay? So here we will have, yeah. He says any 2 out of 3 contact forces are more rigid, less pliable, and decrease the time of contact or final velocity is larger than 0.4 meter per second. Final velocity A is smaller, increases acceleration or force is equals to mv minus mu divided by t, or impulse divided by time. Remember, impulse is change in momentum. Here the impulse, I don't think that impulse will increase. Okay, so don't write this word impulse. So I hope you understand. This was the question number 1. Now we are going to the question number 2. Question number 2 on your screen, he says figure 2.1 shows a small swimming pool containing water. The depth of the water in the pool is 0.80 meter. The density of the water is 1000 kg per meter cube. Question number 2, A part is show that the mass of the water in the pool is approximately uh, 6700 kg. So this is how much marks? This is a 2 marks question. We know the length, the width, and the depth of the water. Very easily we can find the volume of the water because this is a cuboid shape swimming pool. So the volume will be equals to 2.1 multiply 4 multiply 0.80 meter. So you will get the volume. You know the density is 1000 kg per meter cube. So you can find very easily the mass. The mass will be equals to density multiply velocity. The volume. So let's see how my student has done. If she will make a mistake, I will let you know. Okay. So here we go. The volume is equals to length multiply width multiply height. You know the density is mass divided by volume. So in the place of volume, I will write 0.8 multiply 4 multiply 2.1. Density is 1000. So mass will be equals to 1000 multiply 6.72. And that will be equals to 6720 kg. So when you round it off to two significant figures, it will be 6700 kg. So let's check the marking scheme. But the marking scheme has to say question number 2 on your screen. So you can see that we have shown this is how this is done. This was question number 2 and it's A part. Question number 2 is A. Second part, he says define pressure. You know the pressure is the force exerted per unit area or force divided by the area. So this is a very simple definition of a famous question also. So force per unit area is called the pressure. So, okay, so let's go to the next part. Question number 2A, third part. He says calculate the pressure on the base of the pool due to the water. So the force here is the weight of the water and okay. So because the water is a liquid and you know how we calculate the pressure of a liquid, that is rho gh. So here the rho stands for the density, g stands for the gravitational field strength, and h stands for the height, the height of the water. So that is 0.8 meters. So 1000 multiply 9.8 multiply 0.8, and that will be 7840 Pascal. So that will be 7800 Pascal when you round it off to two significant figures. So you can see, look at the marking scheme. I hope you understand this. This is how this is done. The pressure of the water is rho gh, where rho is the density, G is the gravitational field strength, and the H is the depth of the water. Okay, now question number 2 is A, its fourth part. He says the water in the pool is initially at a temperature of 10 degrees centigrade. The temperature rises when 5.1 expo 8 joules of energy is transferred to the water. The specific heat capacity of the water is 4200 joules per kg per degree centigrade. Calculate the final temperature of the water. You know, when the heat is given to a body and its temperature changes, the formula we use is heat is equals to mc delta theta. So, or you can say mc delta t. Sometimes people write it like this. M is the mass of the water, and C is the specific heat capacity of the water, and delta T is the change in the temperature. So first of all, I will find out the change in the temperature. I know the amount of heat, I know the mass, I know the specific heat capacity, and I can find the change in the temperature. We know the initial temperature. Then I will add the change in the temperature in the initial temperature, and I will get the final temperature. This is a 3 marks question. I hope you understand the strategy. So here we go. So the E means the heat is equals to mc delta theta. So energy you provided is 5.1 expo 8 joules, and the mass is 6700 kg and 4200 joules per kg per degree centigrade is the specific heat capacity, and the change in the temperature is final temperature minus the initial temperature. So these two will go downstairs there. So when you do this calculation, you get 18.18. So the final temperature minus the initial temperature, this minus 10 will go to the other initial temperature was 10. So it will add there. So temperature will be 18.12 plus 10. So that's 28.12 degrees centigrade. So the final temperature will be 28 degrees centigrade. So the final temperature, we think that it will be 28 degrees centigrade. Our answer is right. This is how this is done. And we are going to the question number 2 is B part. Explain in terms of the movement of particles how evaporation causes cooling. You see what happens in the evaporation, that the particles who have higher kinetic energy, they leave this from the surface of the liquid and they go into air. The particles which are left in the liquid, they have less kinetic energy. Due to this, what happens? The average kinetic energy of that liquid decreases, and this causes a drop in the temperature. So let's check what the IMA has written. She says more energetic particles escape the liquid, leaving less energetic particles. Average kinetic energy of the particles left in the liquid decreases, and the kinetic energy is directly proportional to the temperature, so the temperature drops. This is what the IMA has written. Have a look at the marking scheme. It says fast-moving or more energetic particles escape, leaving slowest or less energetic particles. So I hope you understand how to write this answer. Okay, question number 2B and its second part. Changes to factors in the environment of the swimming pool can cause an increase or decrease in the amount of evaporation from the surface of the water. State 2 changes to the environment factor that increase the amount of evaporation from the surface of the water. You see that the changes in the environment which can happen and which can cause an increase in the rate of evaporation are the temperature, the room temperature. If the room temperature will increase, the rate of evaporation will increase. If the humidity level in the environment drops, it also increases the rate of evaporation. And if the wind starts blowing, that also increases the rate of evaporation. So these are some of the environmental changes which can happen and they can increase the rate of evaporation. So IMI has written higher temperature and high wind speed. So both factors are correct. So have a look at the marking scheme. He says high temperature, wind, and low humidity. So I hope you understand this statement and question. Okay, so we are going to the next question, and that is question number 3 coming up on your screen. He says, figure 3.1 shows a solar-powered charger connected to a cell phone, mobile phone. Here we have a cell phone, and this is solar-powered charger. The battery inside the cell phone is charged by the solar-powered charger. So question number 3 and its A first part is complete the figure 3.2 to show the useful transfer of energy from the sun to the battery. So energy in the sun, that is, then he says light from the sun. This is happening due to the fusion in the sun, and that is called the nuclear energy. The energy in the sun is due to the fusion, and that is called a nuclear energy. And then light from the sun is electric field in the charger, electrical. And then we have to write energy in the battery. Energy in the battery is the chemical potential energy. In the energy which is stored in the battery, that is chemical potential energy. This is what we think. And he says the nuclear energy in the sun, chemical energy in the battery. So this is what she has written, and I think these are correct answers. So yeah, question number 3, A part, you can see the nuclear energy in the sun and the chemical energy in the battery. The energy stored in the battery is called the chemical potential energy. Okay. Question number 3A and its second part. Explain why the battery takes a long time to charge on a cloudy day. You see, on a cloudy day, because the infrared rays reaching or the sunshine which is reaching the solar charger, that will decrease. So that's why a less amount of EMF will be induced. Okay, he says less light. Okay, as the light reaches solar power charger. She wrote, as less light reaches the solar powered charger. So you can write that less amount of light is no light, no electric current produced. Okay. Then we have question number 3. It's B part. He says after use, the outside surface of the cell phone is warm. When switched off, the cell phone cools down. Name and describe 3 processes by which the thermal energy is transferred as the phone cools down. The 3 ways of energy being transferred from one place to another is conduction, convection, and radiation. Okay, but we have to give the names and we also have to describe a little bit. 2 lines for each process is given. So by the conduction, the heat from the inside the battery through its solid casing by the vibration of the particles will be transferred to the outer side of that charger and of that battery. I mean, the outer casing is solid. Through the solid, the heat is transferred with the help of the vibration of the particles. The particles at the hot end, they absorb the energy and they start vibrating vigorously. The amplitude of their vibration increases. So they collide with the neighboring particles and make them vibrate vigorously. In this way, by the vibrations of the particles, the energy is transferred through a solid from the hot end to the cold end. So this is conduction. And in the convection, what happens? The heat, the air which is near that charger, that battery, I mean. So what happens? That air will absorb that energy and thermal energy from the casing of the battery. And what will happen? The particles of that air will move away from each other. The temperature of that air, which is adjacent, which is in contact with the casing of that battery, that air particles will move away from each other. That air will become hot. That air will become less dense. And this less dense air will rise upward. And the cold air, which is more dense, that will sink down, and convection currents will set around the battery. And by the convection in the air, the thermal energy will be taken away. And the third thing is that the battery also do radiation. By the radiation also, the heat is lost to the surrounding. The hot battery will be emitting infrared rays. So by the emission of the infrared rays, the battery will be losing heat. Okay, the first one is radiation. It is emitted from the surface. Conduction energy passes from particle to particle in solid through vibration, and convection is air particles near cell phone get heated and rises due to less density. The air becomes less dense. Okay, clearly right. Don't just say the particles become less dense. Particles do not become less dense. Say air becomes less dense and it rises and convection currents are set in. So let's have a look at the marking scheme. He says right conduction, convection, and radiation, and you have to write these few lines. The marking scheme is showing up in front of your screen. And you can pause the video and take your time with this one. This is what the IMA has written. I have also tried to explain you. Okay, so now we are on the question number 3, and it's a C part. It takes 4.5 hours to charge the battery with an average current of 300 milliampere. Calculate the quantity of charge that enters the battery. Give the unit of your answer. You know, voltage and charge we know, and we know the current, we know the time, and we want to find out the charge. You know, the I is equals to charge divided by time. I want to know the amount of the charge. The amount of the charge will be equals to the current multiplied time. Current is equals to charge divided by time. So charge will be equals to current multiplied time. But the current must be taken in amperes and the time must be taken in seconds. So, you know, Q is equals to IT, where Q is the charge, I is the amount of current, T is the time. Time must be taken in seconds, and the I must be taken in amperes. So 300 expo minus 3 ampere multiply 4.5 multiply 3600. Why we multiply with the 3600? Because we want to convert hours into seconds. When you do this calculation, you will get 4860 coulomb. So 4860 coulomb, when you round it off to two significant figures, it will be 4900 coulomb. 4900 coulomb. 4900 coulomb is the right answer, sir. Okay, so we are going to the next question, and that is question number 4. And it's coming up on your screen. I hope till now you are understanding. And this is question number 4 coming up on your screen. So we are on question number 4, A part. Figure 4.1 shows light passing through a triangular glass prism. So the light has entered into the triangular glass prism at the point P, at the point Q. The total internal reflection took place at the point R. Again, the total internal reflection took place. And here the light has emerged out of the prism. State the value of the angle of incidence at the point P. The angle of incidence at the point P, you can see this angle. This is the normal and the light is coming on the normal. So the angle of incidence with the normal is 0. The angle of incidence at the point P is 0 degrees centigrade. Let's check what IMA has written. 0 degrees centigrade. I said centigrade. I mean 0 degrees. Okay. So the answer is 0. He says draw the normal at the angle of incidence at the point R. Label the angle of the incidence. So I will draw here the normal. The normal will be making 90-degree angle with the surface at this point of incidence. So this dotted line is the normal, and the angle of incidence here is I, this angle, the incident ray at the R, the angle which is between the incident ray at R and the normal there. So this is how you label it. Then their question is, question number 4, it's A and it's third part. It's a 2 marks question. He says, state 2 conditions needed so that no light refracts from the glass into the air at the point Q. You see here at the point Q, the angle here, the total internal reflection has taken place. At the Q, the light must be traveling in the dense, optically dense medium. And the angle of incidence in the optically dense medium should be larger than the critical angle of the glass prism. So these are the two conditions which must be angle of the incidence greater than the critical angle. Light should move from more dense to the less dense medium. That the point Q should be at the boundary of the optically dense medium and the optically rare medium. So this is my answers. Okay, so I hope you can see the marking scheme as well. Okay, then their question is question number 4, and it's B part. He says information is sent across the internet using pulses of visible light through long, thin glass fibers and optical signals through the copper wire and electrical signals through the copper wire. State the name of one other type of electromagnetic radiation used to transmit information through long, thin glass fibers that is visible infrared. So visible light they have given us, and the other one is the infrared rays. Okay, so just the two advantages of using the glass fiber rather than copper wires to transmit information from the internet. So when you use optical fibers, and they are better in the optical fibers, and the optical fibers are lightweight. The optical fibers, the bandwidth is larger as compared to the copper wires. The reason, because the rate of the data transfer by the optical fiber is greater than the rate of the data transferred through the copper wires. There is less interference in the optical fiber as compared to the copper wires. And you also need less amplifiers or boosters in the case of optical fiber as compared to if you are using a copper wire. So let's see what she has written. Less chance of hacking, less mass. Hacking, I don't think that this word is not good. There is less, you can say, interference. So more calls per second or greater bandwidth or faster speed, less chance of hacking, less interference, less information. In the marking scheme, he says less chance of hacking. That's why I am also wrote there. And less interference, less information or noise, longer transmission distances before losing signal, less attenuation, and thinner or lighter or less mass. So you just have to write 2 out of these. So on your screen, the question number 5 is showing up. An initially uncharged rubber balloon is rubbed with a woolen cloth as shown in the figure 5.1. Rubbing the balloon causes the balloon to have a negative charge. So if the balloon has negative charge, it means it has gained electrons. So balloon gains electrons and now has a negative charge. Woolen cloth loses electrons and now has a positive charge. So their question is their question is on the figure 5.1, complete the labels on the diagram. So balloon gain electrons and now has a negative charge. Woolen cloth loses, you can say, electrons and now has a positive charge. So question number 5, its answers. You can also look at the marking scheme. Question number 5, it's a second part. Explain why the balloon stays negatively charged for a long time. You see, balloon is an insulator. Its material is insulator. So where you rub the surface, the location where you are rubbing it, so the charge will be there on that location because the balloon is insulator. Its material is insulator. So the rest of the balloon is insulator. So that portion where you have rubbed, that will have charge. And because the balloon is insulator, so its electrons which it has gained now cannot go anywhere. Balloon is an insulator, so electrons cannot move through it. Yeah. Electron charge to move through rubber, air, or little ionization in the air caused by the background radiation. Okay. So electrons cannot go anywhere now unless you touch it with your hand. Okay, question number 5, and it's B part. Rubbing the balloon causes the temperature of the air inside it to rise. Explain in terms of the particles of air why the volume of the balloon increases when the temperature of the air rises. Okay. So what happens when you rub the balloon? The temperature of the air inside the balloon increases. So the particles, they start moving faster, and they will have obviously more kinetic energy. So what will happen? They will hit the inside walls of the balloon with more frequency, the collision frequency of collision with the walls of the balloon, inside walls of the balloon will increase, and the because they have higher kinetic energy, now when they collide with the walls of the balloon, they will be exerting more force. So this causes initially an increase in the pressure. So what will happen? The balloon will have, inside the balloon, the air will have more pressure as compared to the atmospheric pressure, which is acting outside, which is trying to squeeze that balloon. So that balloon will have a resultant force in the outward direction. So the balloon will start expanding. So, and at some point, what will happen? Because when the balloon's volume will increase, the gas volume inside, the air volume inside the balloon will also increase. And that will cause, again, a decrease in the pressure. And when the inside pressure and the outside atmospheric pressure, they will become equals to each other, the balloon will no more, it will no more expand. So overall, the change in the pressure, there is no change in the pressure. Initially, there will be an increase in the pressure of the air, but overall, there will be no change in the pressure. The balloon has simply expanded. I hope you understand this explanation. Kinetic energy of the particles increases and they move faster and collide more frequently with the walls of the balloon, and they are exerting greater force. Okay, so this is what the IMA has written. So let's what the marking scheme says. Let's see. Marking scheme says that the particles move faster, particles hit sides more often, more frequently, or with the greater force. So this is what the marking scheme said. I hope you can write this answer. Okay, so we are going to the next question, and that is question number 6. Figure 6.1 shows a circuit diagram containing a battery, a light-dependent resistor, and a fixed resistor of resistance 240 ohm connected in series. So we have here the light-dependent resistor. We also have here a fixed resistor, and that fixed resistor's resistance is 240 ohm. There is a lamp near the circuit. Light from the lamp is incident on the LDR when the lamp is switched on. So here somewhere we have a lamp, and when it's switched on, its light will fall on the LDR. So the LDR, its resistance depends upon the light falling on it. If there is more light, the LDR will have less resistance. And if there is less light falling on the LDR, its resistance will be high. So figure 6.2 shows the circuit voltage graph for the LDR with the lamp switched on and with the lamp switched off. So you can see here, here on the y-axis, the current is represented, and on the x-axis, the voltage is represented. On the y-axis, the current is represented. On the x-axis, the voltage is represented. And we have two graphs here. And one is for when the lamp is switched on, and the other one is with the lamp switched off. And this is a graph of the LDR for the LDR. Okay. So this is basically current and voltage graph. Okay, so if you look at the graph, on the y-axis, the current is represented. On the x-axis, the voltage is represented. The gradient of this graph will be equals to I by V. So that is equals to the reciprocal of your resistance, the resistance of the LDR. So the graph which has larger or higher gradient will have less resistance. And the graph which has less gradient will have more resistance. So this is the basic idea. Let's see what's the question they are asking us on this graph. Their first question is, this is the question number, we are talking about question number 6, and it's a part, and he says, state Ohm's law. Ohm's law says that in through a conductor, the voltage drop across the conductor and the current flowing through the conductor, they are directly proportional to each other, provided that the resistance and the physical conditions of the conductor do not change. In the place of conductor, you can also use the word resistor. Okay, so let's see what Ima has written, how she stated the Ohm's law. Current is directly proportional to the potential difference provided its temperature and physical conditions remain constant. You see, this is not a very complete definition. You should say that the current flowing through a resistor is directly proportional to the potential difference across the resistor provided its temperature and the physical conditions of that resistor do not change. They remain constant. So we are on question number 6, A part, and here we go. So I told you what normally a student makes a mistake, even though she very well knows what is Ohm's law. But when she writes, she do not use the word across a resistors. Explain how the graph lines in the figure 6.2 shows that Ohm's law applies to the LDR. Whenever the Ohm's law is obeyed, the graph between the current and the voltage is a straight line. So the graph is a straight line. This shows that it's obeying the Ohm's law. A graph is a straight line and passes through the origin, and it also passes through the origin. Yes, that is very important. So the marking scheme is showing you in front of you, so you can use that also. Okay. So that was question number 6 and B part. Now we are on question number 6 and C part. He says use values from the figure 6.2 to explain the effect of light on the resistance of the LDR. So I told you in the start of this question that because the current is represented on the y-axis and the voltage is represented on the x-axis, here the gradient of this graph is equals to the reciprocal of the resistance. So from each graph, I will take 2 points. I will note down the coordinates. Then I will find out the gradient. And then I can apply. He says when the lamp is switched off, the resistance of the LDR is 13 ohm. And when the lamp is switched on, resistance is 80 ohm. For the same voltage she is talking. And we can see from the figure also. Okay, so how you can to see, take this point 0 comma 0, take this point which is 8 comma 0.1 for when the lamp is switched on, and you can do I2 minus I1 divided by the V2 minus V1, and you will calculate the resistance. Okay, the resistance will be the reciprocal of this gradient. In the same way, you can find the gradient of this line. You can take the point 0 comma 0 and 8 comma 0.06 and find the gradient of this line, then reciprocate that gradient, and that will be equals to the resistance. She has done that here, but she has not shown the process. When lamp is switched off, resistance of the LDR is 133 ohm, and when the lamp is switched on, resistance is 80 ohm. You can show that calculation. She did that calculation but has not shown here. Please do that calculation. It's very important. Okay. Okay. So then the next question is, the next part is, question number 6, and it's B part. With the help, with the switch, with the lamp switched on, the current in the LDR is 0.050 ampere. Determine the current in the fixed resistor. So because the LDR and that fixed resistor, they are connected in series with each other. So the same amount of the current which is passing through the LDR is also passing through the fixed resistor. So it is 0.050 ampere. This is a conceptual thing because both of these things were connected in series with each other. So they will have the same amount of current through each of them. So then their question is, calculate the electromotive force EMF of the cell. So we know the resistance of the LDR when the lamp is switched on. We know the current flowing through it. We can find the voltage drop across the LDR. We know the resistance of that fixed resistor. We know the current flowing through it. So we can find out the amount of the voltage drop across them because both of them are connected in series with each other. So let's say the voltage drop on the LDR and the voltage drop on the fixed resistor, calculate both of them and then add them up, and that will be equals to the EMF of your cell. So here the voltage drop will be equals to current multiply the total resistance of that circuit. So voltage will be equal to the current flowing through the circuit is 0.05 ampere, and the total resistance of the circuit is 80 plus 240. So it is 0.05 multiplied 320, so that is 16 volt. So the EMF is 16 volt, which is the right answer, sir. This is how this has been done. Because they both are connected in series with each other, so the total circuit's resistance will be 80 plus 240. 80 is the resistance of the LDR when the light is on. So I hope you understand. This was question number 6. Now we are going to the next question, and that is question number 7 coming up on your screen. Question number 7, and here we have question number 7. Okay. So they say that a plotting compass contains a needle. The needle is a small magnet that can rotate about its center. Figure 7.1 shows the plotting compass placed close to a bar magnet. On the figure 7.1, mark the magnetic poles on the bar magnet. Here you see your magnetic compass needle is north is pointing in this to the left. So that means that here the magnetic lines are coming out. So this will be a north pole. This is your 100% north pole. And this is your south pole. Okay? Because from here, the magnetic lines are coming out. You know, the pointer of the magnetic compass always align itself in the direction of the magnetic lines. So if the north of the magnetic compass is pointing towards the left, that means in this area, the magnetic lines are going to the left. That's why we know that from this side of the magnet, the magnetic lines are coming out. So this side is your north pole. So I hope you understand this, and let me show you from the marking scheme. Okay, this is how we have shown here. Okay, so then the marking scheme, what does the marking scheme say? Question number 7. Okay, so the marking scheme of the question number 7 is showing up on your screen. Our answer is right. Okay, so then what they say? Then the question number 7A and its second part is, they say there is a piece of paper underneath the magnet, and describe how the compass is used to plot the magnetic field line that passes from one pole to the other through the point P. Okay, so very simple. I can put a magnetic compass here at the point P, and I will put it in such a way that its back of the pointer is coinciding with this dot. Wherever the arrowhead of that compass will point, I put a dot there. Then I will place my magnetic compass and in the next location in such a way that the tail of the magnetic compass coincides with the dot which you have put on the paper. And wherever the pointer of that magnetic compass will direct point, put a dot on the paper there. You keep on doing this process until you reach the South Pole. In the same way, you can put the magnetic compass here before the point P, and pointer should be coinciding with this dot. Wherever will be the arrow of that magnetic, the tail of the magnetic magnetic compass pointer, put a dot on the paper. Then again, put the magnetic compass here, such a way that the pointer of the magnetic compass is coinciding with that dot, the head of that pointer. And wherever will be the tail of that magnetic compass, just put a dot on the paper and continue doing this. You are going reverse until you reach the North Pole. Then you can join these dots which are on the paper, and they will go from north, they will pass through the P, and they will go into the south. So this is how I just described. It's a 3 marks question. So let's see how the Miss Aima has written this. Okay, so let's see what she wrote. Place one end of the compass needle on the point on the P and mark its head north and tail south on the paper. Move compass so that its tail coincides with the marked point. Continue round the field line and for other lines and join marks. So this is not a very impressive answer. Okay. So place one end of the compass needle at the P and mark the other end of the needle on the paper. Move compass on so other end is next to or on the marked point. Continue round field line and for other lines and join those marks. So just write this. This experiment is also written in your textbook. Then the question is, describe how to use the compass in the figure 7.1 to determine the direction of the magnetic field at the point P. You simply place the magnetic compass at the point P, and wherever the pointer of the magnetic compass will point, that is the direction of the magnetic field at the point P. So let's check what my student has written. Place compass on the P, and where the north pole of the compass needle points is the direction of the magnetic field. So this is what she has written, and this is an answer. So let's look at the marking scheme, and you can read the marking scheme. You can pause the video. You can take your time. Okay. Then we have next question, question number 7B part. He says, figure 7.2 shows the apparatus a student uses to produce an alternating current. So here we have a magnet, a bar magnet in your hand. Here we have a coil. The coil is connected with a center 0 ammeter. The magnet is moved into and out of the coil. Explain why a current is produced when the magnet moves. Okay, so when you will be moving this magnet relative to this coil, so when the magnet is coming closer, so the number of the magnetic lines passing through this coil will change. And when you are moving away from the coil, even then the magnetic lines passing through this coil will change. So when you are moving it forward, backward, what is happening? The magnetic flux which is passing through this coil is changing, and this is the Faraday's law of magnetic induction, that when the magnetic flux passing through the coil changes, automatically EMF is induced in that coil. So the current is induced in that coil. So let's see what Aima has written. She says that the magnetic flux. Okay, here we go. So the magnetic flux passing through the coil magnetic flux change in the coil and induces an EMF is the very simple, straightforward answer. So magnetic field cut the coil, or coil flux field change in the coil induces an EMF by the induction. So I hope you understand this very famous idea on which this question has been asked. Describe the movement of the magnet that produces an alternating current of the frequency 0.5 hertz. So if you want a current of alternating current of 0.50 hertz, your hand movement should also have this frequency. So your hand should also have this frequency. We can also say, and you can find the time period. Aima has written the time period there. If you reciprocate the frequency, if your frequency is 0.50 hertz, you reciprocate it, the time period is equals to 1 by f. So 1 divided by 0.50 hertz will be 2 seconds. So in 2 seconds, the magnet moves in and out of the coil. Okay. So move the magnet in and out of every 2 seconds, or 0.5 times in 1 second. Describe how the center zero ammeter shows the current in AC rather than DC current. You see how center zero, because in the center zero, the pointer is in the center. So the pointer can move to the left, pointer can move to the right, depending upon the current which is passing through that ammeter. So you will observe that in half of the movement of your hand, in one complete cycle of your forward and backward, that's a complete cycle of your hand. You are holding a bar magnet. So during the half of the cycle, the ammeter will be deflected towards the right, and during half uh, cycle, the ammeter will be deflected to the left, so that the pointer will be deflecting to the right, then to the left, then to the right, then to the left. So that shows that alternating current is being produced. The direction of that current is changing. Reading shows positive and negative, means pointer will be moving left and right, left and right. So moving magnet in order, okay, so the reading positive and negative, both sides of the zero. Yeah, the pointer will be moving both sides of the zero, which shows that the alternating current is being induced. Okay, then their question is, explain why increasing the frequency of the alter, explain why increasing the frequency of the AC produce also increases the magnitude of the AC alternating current produced. You see, if you want to increase the frequency of the alternating current to produce, you have to move that bar magnet quickly. You have to move that bar magnet faster. So your movement of your hand should have a higher frequency. So when the bar magnet moves relatively to the coil faster, a larger amount of the current is induced. Okay, because there will be a larger change in the flux in the same time duration. the rate of the change of magnetic flux increases. That's why there will be a larger amount of the EMF induced. This is what we think, larger rate of change of field or flux or larger rate of cutting of the field line. So this was question number 7. The marking scheme is showing up on your screen. You can pause the video and you can take your time. And okay, so we are going to the next question. The next question coming up on your screen is question number 8. And let's see. Oh. So question number 8 is showing up on your screen. Figure 8.1 is a picture of nebula formed from a supernova. State what is meant by a supernova. Supernova is kind of an explosion which happens in the life of a explosion of a red giant star at the end of its life cycle is called a supernova. Okay, so supernova is basically an explosion of a red giant or a massive star, and at the end of its life cycle. So supernova is an explosion in the life of a massive star. Once it's a red giant, after the super red giant, the supernova takes place. So the marking scheme is a 2-mark question. I hope you understand. Okay, question number 8 is B part. Describe how a protostar forms inside a nebula. You see, in the protostar, what happens? This is about the birth of the star. You see what happens, that the dust and the gases, they come close to each other. And due to the gravity, the density of that cloud increases. And due to this, the temperature of that cloud also increases. And so that cloud of dust and gases becomes more dense. Its gravity increases, the inward force increases, and that increases the temperature. And what happens due to that, the fusion of the hydrogen starts. And due to that, the temperature further rises and the star becomes a protostar. It starts shining. So let's see. He says the clouds of dust and gas collapse due to gravitational attraction, resulting in an increase in the temperature. So temperature becomes very high due to very strong inward force. So the clouds of dust, gas come together, and that they are trying to collapse that cloud of the dust and gas due to the gravitational attraction, or resulting in an increase. So the very strong pressure, inward force, the particles come close to each other, and the temperature of that thing rises. So a protostar is formed from that dust and gas. So this is their answer. This is the next question they are asking is, Baba? Their question is C part. Our sun is in a circular orbit around a black hole at the center of our galaxy. State the name of the galaxy that contains our sun. The name of the galaxy in which our sun is, our solar system is, the name of that galaxy is Milky Way. The name of that galaxy is Milky Way. So the name of that galaxy is Milky Way. So let's have a look at the marking scheme. Milky Way is the answer. So, okay. So then we have state what is meant by a light year. This is the C part, it's second portion, question number 8, C part, second portion. State what is meant by a light year. Light year is basically the unit of distance, and it is the distance traveled by the light in 1 year. Okay, so the distance traveled by the light in 1 year. Okay, so we are going to the next, that is question number 8, it's C part and its third portion. The time taken for one complete orbit of our sun around the black hole is 7.3 into 10 to the power 15 seconds. The distance from our sun to the black hole is 26,000 light years. In one light 1 light year, in 1 year, there are 3.2 expo 7 seconds. Speed of the light is 3 into 10 raised to power 8 or 3 expo 8 meter per second. Calculate the speed of our sun as it orbits the black hole. Show your working and give your answers in meter per second. So uh, we know the speed of that light, and we know the time taken. The orbital speed is equal to 2 pi r divided by time. So 2 is 2, pi is pi. R is 26,000 multiplied 3.2 into 10 power 7 multiplied 3.0 into 10 raised to power 8. This is the distance traveled by the light, and he has given you the time also. So speed multiplied time. So divided by the 7.3 into 10 raised to power 5. So the orbital speed will be 214,833. So 21000 meter per second. So let me tell you the time taken for one complete orbit of our sun around the black hole. Okay. So this is the time for complete that one orbit. And the distance from our sun to the black hole is 26,000 light years. So the radius is 26,000 light years. So that's why 26,000 multiply the time in 1 year in seconds, multiply the speed meter per second. And this is the orbital, the time period, the time required to complete one orbit around that black hole. So this is when you round it off to two significant figure, this is the answer you get. So I hope you understand this. And the orbital speed is equals to 2 pi r divided by time, where the r is the radius of that orbit in which the sun is moving around that black hole. And the time here means the time taken to complete one orbit around that black hole. Its time is given. And the distance of that, the radius is also given, but that is given in the light years. So we converted this into meters. I hope you understand this. This is a little tricky one. Okay, question number 9 is showing up on your screen. He says alpha particles are sometimes emitted from the nuclei of radioactive elements. This emission is both random and spontaneous. Describe what is meant by spontaneous. Spontaneous means immediately. The meaning of this word is this happens all of a sudden, happens by itself. Okay. So spontaneous means that it happens by itself. So this was the marking scheme which we have used, and now we are on the question number 9. It says happens by itself, is not affected or caused by external conditions, for example, temperature, pressure, another nuclear emission, etc. Not affected by the length of time the nucleus has already existed, happens for no reason. That is meaning of the spontaneous. Okay. Then their question is describe the composition of an alpha particle. Alpha particle is like the nucleus of helium. The alpha particle is like the nucleus of helium. It has 2 neutrons and 2 protons. It's not like an atom of helium, it's like the nucleus of helium. It has 2 neutrons and 2 protons. It has 2 protons and 2 neutrons. This is the composition of the alpha particles. Okay, then we have the question, next question. I mean the question number 9, it's C part. He says, the alpha particles are detected using the tracks shown in a cloud chamber or by the sparks produced in a spark counter. Describe the structure of either a cloud chamber or spark counter. Include a labeled diagram of the apparatus. Okay. So it's a 3 marks question. So we are going to talk about the cloud chamber. And in the cloud chamber, you see it's very simple what we do. You see here we have at the bottom, we have taken a container which is a transparent container. The top is transparent, and at the bottom, what we do, we put some foam for insulation, and then on that foam, we put a solid carbon dioxide. Solid carbon dioxide is called dry ice, and that is very, very cold, and it is used to keep the things cold, dry ice. So we'll put a layer of dry ice here, then we put a carpet on here. The color of the carpet should be black, and then we do, we take some cotton and we soak it in the alcohol, and we place it here, and then we place a source of the radioactive substance, and then we have transparent top on that, and here we have a source of light. So basically what happens here, the vapors of the alcohol will be produced, and because of this radioactive sample, it will be emitting alpha particles, maybe beta particles, maybe gamma particles, but it is emitting radiation. So what happens due to that radiation? The air particles here, they will be ionized, and the vapors of that alcohol, they will attach themselves to those ionized air particles. So because of this light, wherever the ionized particles will have alcohol vapors attached with them, so there a bright light will be shown. So basically what will happen, you will be able to see when you were looking from the top, switch off the lights of your laboratory, and then just wait and look from the top inside. And what you will see that the sparks are being produced. If those sparks are straight lines, long straight lines, thick lines, that means the alpha particles are being emitted. If those lines are long and they are little wavy, that means the beta particles are being produced. And if those lines, which of the bright lines which are produced, the sparks which are produced, if they are wavy, they are broken, they are not. So that means that the gamma radiation is being produced. Here, the whole thing is how much the ionization of the air is being done. So this is what I have to say, and let me read the answer which my student has written. So let's see what she has written, so we can have an idea how the student writes. Okay, dry ice, solid carbon dioxide is at the bottom of a transparent box with a transparent lid to see clearly from above. Place radioactive sample above the dry ice, cotton soaked in the alcohol. Okay, so this is what she has written. I just gave you his is. Okay, this is the outline of the cloud chamber with either light or transparent window for viewing. Source of the vapor, for example, alcohol. Method of cooling, clear, for example, expand, piston, or dry ice. We have placed dry ice. Time between tracks formed varies. A number of tracks in a certain time varies, or tracks go in any direction. Okay, so this is how this happens, and it's a 3 marks question. Just few lines are given for you to write. Describe how the emission of the alpha particles is shown as random in the apparatus you described in the C first part. Uh, Whenever the alpha particles will be produced in the cloud chamber, uh, they are random. Their emission is random. So the time duration between the sparks you cannot predict, and the direction of those sparks you will not be able to predict. That everything will be random. Random means that we cannot predict that in which direction those sparks will go and at what time they will go. So she says rays formed are random. Those sparks produced in the cloud chamber, they will be random. Time between the tracks formed varies. Tracks go in any direction, not in any particular direction. So let's see what the marking scheme says. Okay, here we have. So time between the tracks formed varies, or number of tracks in a certain time varies, or tracks go in any direction. This shows that the emission of the alpha particle is random. Okay, So now we have question number 3 and its third part. A radioactive source produces 120 tracks in 1 minute in a cloud chamber. 6 hours later, the same source produces 15 tracks in 1 minute. Without the source present, no tracks are produced. Calculate the half-life of the radioactive isotope in the source. So the time is 1 minute. Okay, so no, 6 hours later. Okay, so the time passed has 6 hours. So the number of tracks has gone from 120 to 15. So the way we do this question is we make this grid. So at the start, this was 120, so 120 half, and that's 60. Again half, and it becomes 30. Again half, and it becomes 15. If you count these half, these portions, so there are three portions. That means 3 half-lives have passed. Total time taken is 6 hours for this thing. So 6 divided by the 3, that is 2. So that means the half-life is 2 hours. So the half-life is 2 hours. So let's check from the marking scheme. So the half-life has passed is 3 hours. Okay. So my dear students and so my dear students, you see we have done today we have done May June 2024 Physics 5054 2 paper in this video. I have tried my best to explain you, to give you the idea and the concept, and I hope that this video will be helpful to you. And if you find this video helpful and useful, please share the link of this video with your friends, with your junior students, with your senior students, with your teachers. Share the link of this video on your WhatsApp, on your Instagram, on your Facebook, on your Snapchat, on your LinkedIn. You see, when you like this video and when you share the link of this video on your social media, that helps me, that supports my work, and your support is very, very important. One very important thing is that all the credit goes to the Cambridge Assessment International Education, because in this video, the paper, the marking scheme, the examiner report, which I have used, is the property of the Cambridge Assessment International Education. I have simply downloaded these papers from their website and I have used them in this video. So we are thankful to the Cambridge Assessment International Education for providing us these papers. So these papers, the marking schemes, they are the property of the Cambridge Assessment International Education. So I hope this video will be helpful to you. Thank you very much for taking your time and watching this video. Have a good day.